And now let us see what are the applications of NMR. There are 4 applications. First one is the structure determination, then intermolecular exchange reaction, then hydrogen bonding studies, then NMR imaging. We can determine first of all, structure determination means we can determine the molecular structure. We can determine molecular structure using NMR. How the molecular structure is determined? We use 2 parameters for determining the molecular structure. The structure determination. The first application, structure. Now here we use 2 parameters that we have already studied. The first one is the chemical shift. Delta, and the second one is the spin coupling constant. Spin coupling constant J. For structure determination we use 2 parameters. One is chemical shift delta and spin coupling constant J. And from the chemical shift, if we observe chemical shift, and from that chemical shift you can determine the functional group present in the molecule. Functional group present, and from the spin coupling constant we can determine the arrangement of atom. We can determine the arrangement of atoms in a molecule. Arrangement of atom. This is how the structure determination is possible in NMR. That is, the elucidation of molecular structure using NMR spectrum is essentially the determination of chemical shift and spin coupling constant. So in NMR we are actually measuring the chemical shift and spin coupling constant. The chemical shift of the signal gives us the idea about the functional group in the molecule, and spin coupling constant determines the arrangement of atoms. Then the second application is you can use the NMR to determine the exchange reaction. That is, if a nucleus undergo exchange between 2 chemically different sites, then the information about the exchange reaction can be obtained from NMR. Then the next application is hydrogen bonding studies. If you observe the chemical shift, then you can see that delta of hydrogen, the chemical shift of hydrogen bonded proton, the chemical shift of hydrogen bonded proton is more than the delta of normal proton. If we determine the chemical shift, then for hydrogen bonded proton the chemical shift will be higher compared to normal proton. Therefore the measurement of the chemical shift will give the idea about the hydrogen bonding present. Then the next application of NMR, it is the well-known application, that is the nuclear magnetic resonance imaging, that is NMRI. Is a new diagnostic technique that has revolutionized medical imaging and biomedical research. We usually say about MRI scan, is it? It is actually the nuclear magnetic resonance imaging. What is the principle of MRI? Why human body is MRI active? It is because 80% of the atoms in human body are hydrogen atom, and therefore MRI can be effectively applied. This is the most important application of MRI. Important application. MRI, magnetic resonance imaging, is a diagnostic technique. So there are 4 applications. One is the structure determination. The structure is determined in NMR by measuring the chemical shift and spin-spin coupling constant. From the chemical shift, you will get an idea about the functional group present, and from the spin-spin coupling constant, you will get an idea about how the atoms are arranged. Then the next application is to get an idea about the exchange reaction. Then hydrogen bonding studies. This is because the chemical shift of the signal from the hydrogen bonded proton is greater than normal proton. So by measuring the chemical shift, you can estimate the strength of the bond. The fourth one, the most important application of NMR, this is magnetic resonance imaging, MRI. It is a diagnostic technique that has revolutionized medical imaging and biomedical research. Why human body is NMR active means 80% of the atoms in the human body are hydrogen atoms, and therefore MRI can be effectively applied. These are the applications of MRI.